Good morning, everyone. Today we are going to learn about Amazon EC2. Amazon Elastic Cloud Compute is a web service that provides secure, resizable compute capacity in the cloud. Using this service, you can create and run virtual machines in the cloud. An EC2 instance is a virtual server that you can use to run applications in Amazon Cloud. When setting up EC2 instance, you can configure CPU, storage, memory, and networking resources. You can also choose from different types of instances according to the budget needs. It is similar to the on-premises server, which is required to host web applications, install database, and other software. So while purchasing the server, you have to specify the hardware configuration of the server beforehand, like how much RAM, storage, and compute power will be required. While predicting the required compute power, there can be two scenarios. You may overestimate the requirement and buy stacks of servers which will not be used later on, or you may underestimate the usage, which will lead to the crashing of your application. Moreover, purchasing the server and installing operating system and other softwares on the server would take a lot of time and money. And if you find later on that the hardware you required is not sufficient, then you may have to purchase another server and repeat the entire process. If you are using EC2 instances, then you can easily scale up or scale down number of server instances if your computing requirement changes. You can use Amazon EC2 to launch as many or as few virtual servers as you need. Amazon EC2 enables you to scale up or scale down to handle changes in requirements, reducing the need to forecast the traffic. There are two key concepts that are for launching instances. First is instance type. It determines the hardware of the host computer. Each instance type offers different compute memory and storage capabilities. Second is AMI, which is Amazon Machine Image. It is a template that contains software configuration, for example, an operating system and applications, etc. So as told, AMI is a template that contains software configuration, for example, operating systems, server applications, and other softwares. From an AMI, you launch an instance, which is a copy of AMI running as a virtual server in the cloud. You can launch multiple instances of the AMI. Once the instance is launched, it keeps running until you stop, hibernate, or terminate it. If the instance fails, you can launch a new one from the AMI. An instance is a virtual server in the cloud. Its configuration at launch is a copy of AMI that you specified when you launch the instance. You can launch different types of instances from your AMI. So here you can see that from this particular AMI you can launch single instance or you can launch multiple instances. You can select an AMI to use based on the following characteristics: region, regions and zones, operating systems, architecture, launch permissions, storage for the root device. There are four sources of AMIs. First is published by AWS, the AWS Marketplace. Another one is generated from existing instances, uploaded from virtual servers. So first one is published by AWS. AWS publishes AMIs with versions of many different operating systems, both Linux and Windows. These include multiple distributions of Linux like Ubuntu, Red Hat, Amazon, and Windows 2008, Windows 2012, etc. Launching an instance based on the AMI will result in the default operating system settings, similar to the installing an OS from standard OS ISO image. As with operating system installation, you should immediately apply the appropriate patches upon launch. Second is the AWS Marketplace. AWS Marketplace is the online store that helps customers to find, buy, and immediately start using the software and services that run on Amazon EC2. Many AWS partners have made their software available in the AWS Marketplace. This provides two benefits. The customer does not need to install the software, and the license agreement is appropriate for the cloud. Instances launched from AWS Marketplace AMI incur the standard hourly cost of the instance type plus the additional per hour charge for the additional software. Some open source AWS Marketplace packages have no additional software charge. Then is generated from existing instances. An AMI can be created from existing Amazon EC2 instance. This is very common source of AMI. Customers launch an instance from the published AMI and then the instance is configured to meet the customer's corporate standards for update management, security, and so on. An AMI is then generated from the configured instance and used to generate all instances of that operating system. We can also upload virtual servers using AWS VM import export service. Customers can create images from the various virtualization formats, including RAW, VHD, VMDK, and OVA. Once launched, instance can be managed over the internet. AWS has several services and features to ensure that this management can be done simply and securely. Now we'll discuss instance type. Determines the hardware of the host computer. Each instance type offers different compute memory and storage capabilities. Select an instance type based on the amount of memory and compute power that you need to run applications or software that you plan to run on the instance. Instance types are grouped into families based on the ratio of these values to each other. There are dozens of instance types available varying in the following dimensions: virtual CPUs, memory, storage, and network performance. Now, types of instance types. First is general purpose, compute optimized, memory optimized, storage optimized, and accelerated computing. In general purpose instances, they provide a balance of compute, memory, and networking resources and can be used for a variety of diverse work. These instances are ideal for applications that use these resources in equal proportions, such as web servers and code repository. Examples of general purpose instances are T2, T3, A1, M4, etc. Now, second type of instance type is compute optimized. These instances are ideal for compute intensive applications that benefit from higher performance processors. Instances of the family are well suited for batch processing workloads, high performance web servers, dedicated gaming servers, and other compute intensive applications. In memory optimized instances, these are designed to deliver fast performance for workloads that process large datasets in memory. So, if the application requires a lot of memory, then we can use memory optimized instances. Then, storage optimized. In storage optimized instances, these are designed for workloads that require high sequential read and write access to very large datasets on local storage. They are optimized to deliver tens of thousands of low latency random input output operations per second to the applications. So the applications which require high speed input output operations may opt for this particular type of instances. Then accelerated computing, also known as GPU based instances. In accelerated computing instances, they use hardware accelerators or co-processors to perform functions such as graphic processing or data pattern matching. Now, instance families. C for compute optimized for workloads requiring significant processing. R3 memory optimized for memory intensive workloads. IO2 storage optimized for workloads that require high amounts of fast SSD storage. Then G2 based instances intended for graphics and general purpose GPU compute workloads. Now, within each instance family, there are several choices that scale up linearly in size. Figure shows the four instance sizes in M4 family. Note that the ratio of virtual CPUs to memory is constant as the sizes scale linearly. The hourly price for each size scales linearly as well. For example, the M4X large instance costs twice as much as the M4 large instances. So here you can see that the ratio of virtual CPU to memory is constant as the sizes scale linearly. Securely using an instance. Once launched, instance can be managed over the internet. AWS has several services and features to ensure that this management can be done simply and securely. Now, how can we address an instance? There are several ways that an instance may be addressed over the web upon creation. First is public domain name systems. When you launch an instance, AWS creates a DNS name that can be used to access an instance. This DNS name is generated automatically and cannot be specified by the user. Second is public IP. A launched instance may also have a public IP address assigned. This IP address is assigned from address reserved by the AWS and it cannot be specified. This IP address is unique to the internet and persists only while the instance is running and cannot be transferred to another instance or another customer. An elastic IP address can also be given to an instance. An elastic IP address is an address unique on internet that you reserve independently and associate with Amazon EC2 instance. This IP address persists until the customer releases it and is not tied to the lifetime or state of instance. So that means even if the instance is terminated, elastic IP address persists. Now, how to access EC2 instances? Amazon EC2 uses public key cryptography to encrypt and decrypt login information. Public key cryptography uses a public key to encrypt a piece of data and an associated private key to decrypt the data. These two keys together are called key pair. Key pairs can be created through the AWS Management Console, CLI or API, or the customers can upload their own keys also. AWS stores the public key and the private key is kept with the customer. The private key is essential to acquire secure access to the instance for the first time. You can connect to your EC2 instance using SSH protocol. You need to store your private keys securely. When Amazon EC2 launches a Linux instance, the public key is stored in the .ssh/authorized keys file on the instance and initial user is created. The initial username can vary depending upon the operating system. For example, the Amazon Linux distribution initial user is EC2 user. Initial access to the instance is obtained by using EC2 user and the private key to log in via SSH. Now, how to use Windows login? When launching Windows instance, Amazon EC2 generates a random password for the local administrator account and encrypts the password using the public key. Initial access to the instance is obtained by decrypting the password with the private key either in the console or through API. The decrypted password can be used to log on to the instance with the local administrative account via RDP. At this point, you can create other local users and connect to the Active Directory domains. Now you can choose security groups or you can create your own security groups. Security groups allows you to control the traffic in and out of your instance through virtual firewall called security groups. Security groups allows you to control traffic based upon the port protocol and source destination addresses. Security group have different capabilities depending upon whether they are associated with Amazon VPC or Amazon EC2 Elastic Classic. Security groups are associated with instances when they are launched. Every instance must have at least one security group but cannot have more. A security group is default deny, that is, it does not allow any traffic that is not explicitly allowed by the security group rule. A rule is defined by the three attributes shown in the table. When an instance is associated with multiple security groups, the rules are aggregated and all the traffic allowed by each of the individual groups is allowed. The security group attributes on which our rules are based are: one is port number specified. Second attribute is protocol, the communication standard for the traffic affected by this rule. Another attribute is source destination. It identifies other end of the communication, the source of the incoming traffic rules or destination of the outgoing traffic rules. Example, CIDR block style definitions that define the specific range of IP addresses. For example, if a security group A allows RDP traffic from 72.52.00/16 and the security group B allows HTTP and HTTPS traffic from 000/0 and your instance is associated with both groups, then both RDP and HTTPS traffic will be allowed in your instance. In order to avoid termination by accident command, we can set termination protection on. So, in order to prevent termination via AWS Management Console, CLI, or API, termination protection can be enabled on the instance. While enabled, calls to termination the instance will fail until termination protection is disabled. So now we'll discuss pricing options. You are charged for Amazon EC2 instance for each hour that they are running in state. Now pricing options vary for on-demand instances, reserved instances, and spot instances. On-demand instances. The price per hour for each instance type published by AWS website represents the price for on-demand instances. This is the most flexible pricing option as it requires no upfront commitment. The customer has control over when an instance is launched and when it is terminated. It is the least cost-effective of three pricing options per compute hour, but its flexibility allows customers to save provisioning a variable level of compute for unpredictable workloads. Then is reserved instances. The reserved instance pricing option enables customers to make capacity reservations for predictable workloads. By using reserved instances for these workloads, customer can save up to 75% over the on-demand hourly rate. When purchasing a reservation, the customer specifies the instance type and availability zone for that reserved instance and achieves a lower effective hourly price for that instance for the duration of reservation. An additional benefit is that capacity in the AWS data center is reserved for that particular customer. There are two factors that determine the cost of reservation: the term commitment and payment option. Then spot instances. With spot instances, customers specify the price they are willing to pay for a certain instance type. When the customer's bid price is above the current spot price, the customer will receive the required instances. The instances will run until the customer terminates them. The spot price goes above the customer's bid price. There is not enough unused capacity to meet the demand of spot instances. Now, while configuring EC2 instance, you need to choose the instance store. The instance store provides temporary block level storage for your instance. The storage is located on the disk that are physically attached to the host computer. An instance store is ideal for temporary storage of information that changes frequently, such as buffers, caches, and other temporary content, or for data that is replaced across a fleet of instances, such as load balanced pool of web servers. You can specify instance store volumes for an instance only when you launch it. You don't detach an instance store volume from the instance and attach it to a different instance. The data in an instance store persists only during the lifetime of its associated instance. If an instance reboots, intentionally or unintentionally, the data in the instance store persists. However, in case of following circumstances, the data may be lost permanently. First is the underlying disk drive fails, the instance stops, the instance hibernates, the instance terminates. So you need to be very careful about these. Here, instance store provides basic block level storage for the EC2 instance. Storage is located on the disk which are physically attached to the host computer. Therefore, do not rely on the instance store for valuable long-term data. Instead, use more durable data storage such as Amazon S3, Amazon EBS, or Amazon EFS. Instance store also determines the type of hardware for the instance store volumes. While some provide hard disk drive instance stores, other instance types use solid state drives SSD to deliver very high random input output performance. Data in the instance store is lost when instance terminates or instance stops or disk drive fails. Another type of storage available is Amazon EBS. Amazon EBS provides persistent block level storage volumes for use with Amazon EC2 instances. Each Amazon EBS volume is automatically replicated within its availability zone to protect you from component failure, offering high availability and durability. To make the volume available outside the availability zone, you can create a snapshot of EBS volumes and restore it later on. Multiple Amazon EBS volumes can be attached to a single EC2 instance, although volume can only be attached to a single instance at a time. You can also detach an EBS volume from an instance and attach to the another instance. You can dynamically change the configuration of the volume attached to the instance. EBS volumes can also be created as encrypted volumes using EBS encryption feature. EBS provides the following type of volume types: general purpose SSD, provisioned IOPS SSD, throughput optimized HHD, and cold HHD. General purpose SSD volumes balance price and performance for wide variety of transactional workloads. Provisioned IOPS SSD volumes are designed to meet the needs of IO intensive workloads that are sensitive to storage performance and consistency. Throughput optimized HHD volume provides low cost magnetic storage that define performance in terms of throughput rather than IOPS. Then cold storage volumes. Cold HHD volumes provide low cost magnetic storage that defines performance in terms of throughput rather than IOPS. If you require infrequent access to your data and are looking to save cost, these volumes provide inexpensive block storage. Backup snapshots. You can back up the data on your EBS volumes regardless of volume type by taking point in time snapshots. Snapshots are incremental backup, which means that only blocks on the device that have changed since your most recent snapshots are saved. Data for snapshot is stored using Amazon S3 technology. Now recovering volumes. Because Amazon EBS volumes persist beyond the lifetime of an instance, it is possible to recover data if the instance fails. If an Amazon EBS backed instance fails and there are data in the boot drive, it is relatively straightforward to detach the volume from the instance. Unless the delete on termination flag for the volume has been set up to false, the volume should be detached before instance is terminated. The volume can then be attached as a data volume to another instance and the data can be recovered easily. So this is how you can recover the data from the EBS volumes. This is how you can create and configure your EC2 instances in AWS. Thank you.